Okay, now continuing from where we left off last time. This is May, June 2017. Variant 5-1. Question number 1. We already did part A, so now we're going to start with part B. So part B is explain why the student took readings between 0 minutes and 2.5 minutes. This is this area. They're asking why did he take readings for this area, which I have highlighted in pink. Why did he take readings between when the minutes were 0 and when they were around 2.5. During this interval, why did he take readings? And we did this before, that when we start an experiment like this, first we insert the thermometer, and then for the first few beginning seconds we record the room temperature, and obviously the room temperature keeps coming constant because obviously it's constant, so we get this kind of straight line over here. For every second, after 1 second, 2 seconds, 3 seconds, we get the same temperature, so it's a constant temperature, so we get a straight line over here. So that's the answer. You just have to mention 2. Okay. Now the second question is, part C is explain why the student did not take a reading at 3 minutes. They're asking why we don't have a reading at 3 minutes. If we take this line up, we see that at 3 minutes we don't have any cross. And why don't we have this cross? The reason is because at this particular minute we are adding the calcium chloride has actually started its reaction. Okay, so you can say that this is the time point where the small bag bursts open and the reaction start. So this is the point where you're applying pressure. So obviously you can't take the reading for the temperature at this point. So I'll just write the answer that we have in the mark scheme. Actually, you don't have to go and check the mark scheme after seeing this video, because all of these answers that I wrote are the ones that are like suggested by the mark scheme itself. But obviously I explain everything, every part over here as well. Why do I feel like this pen is working really slowly? Now, this explains why the temperature continues to increase between 3.5 minutes and 4.5. It's this part that they're talking about, this part. Okay? So for the answer for part 1D is this. Now for part E, you need to draw two straight lines of best fit on this graph, and you have to extrapolate, as in extend these lines to estimate the theoretical temperature rise. Like first, how much temperature rise was there from your room temperature when the calcium chloride started its reaction. And you have to give the answer to 1 decimal place, because this question is of 2 marks and 1 mark is for you to give your answer in 1 decimal place. So I can't really do this over here, because obviously if you have this question on paper, you're going to take a scale and you're going to draw these lines of best fits, and I can't do this over here. So I'll just show you. You're supposed to make a line like this, okay, and then you're supposed to make a line of best fit somewhere over here, and then you're gonna see the point where these 2 lines intersect, right? And you're gonna see if the temperature over here was like, the temperature over here is at this point, it's 21.5, and then you have to see what is the temperature that you're getting when you are gonna match. You're gonna see the intersection of this line and your graph, whatever your line of best fitted, that intersection point, what is the temperature at that particular point, okay? And then you're gonna take that temperature, I'm just gonna suppose that as T, okay, I'll just suppose it as T, and then you'll do T minus 21.5 is equals to, and then you'll get this thing, the theoretical temperature rise at 3 minutes. I was getting it somewhere, I think the answer is somewhere between 16 degrees Celsius and 17 degrees Celsius. The marking scheme, they don't specify a really specific answer. They just say that 1 mark is for the theoretical temperature rise, your answer being to 1 decimal place. So it's, if it's like 16, so you have to write it like this, or maybe if it's 16.5, you have to write it like this. If it's 16.9, you're supposed to write it like this. If it's 17, you're supposed to write it like this. You need to have this 1 decimal you need to have your answer to 1 decimal place. If you, for example, write it like 16, just 16, or you just write just 17, so you're just going to get 1 mark over here. And the second mark is, they say that the cooling curve has a straight line of best fit. The cooling curve is this curve, okay? This curve, okay, you're going to have a straight line of best fit, so you're not going to have this kind of wiggly curve. You're going to like have something like a line of best fit, which is like, you know, which passes through all of the points. It's like, you know, near all of the points, you're going to have a straight line of best fit, and you're going to extrapolate it till 3 minutes. So you have to see. Okay, so we have it till 3. And along with this, you need to have a straight line connecting all of the points from 0 to 2.5 minutes, and that is also supposed to be extrapolated or extended to 3 minutes or beyond. So you're supposed to take this line and you're supposed to extend it, okay? And then you're gonna see at time 3, you're gonna see at time 3 seconds, okay? One line is weird, but, and then you're gonna see the temperature over here, okay? Maybe it's like 38. I'm just taking this because my working is rough, it's not accurate, so I'm just doing it. We saw that it was, if you go over here, we have something like 38. So if we do 38 minus 21.5, I'm taking my T as 38. So if you do this, Our answer is 16.5. So this is not the accurate answer because obviously my line of best fit isn't exactly the line of best fit. I just made it up. Like I just drew it roughly. So you're gonna write it 16.5 over here, okay? So we're done with part B, we're done with part C, we're done with part D, we went done with part D.